Oh, so in this video, we're going to state the chain rule. And the chain rule is simple enough to state. It's a rule for taking the derivatives of compositions. And it says to differentiate a composition. I'll mix my notation here. We've got f of g of x, and we want to differentiate it. Well, a composition is a way of combining functions, and whenever you have a composition, you've got an outside function and an inside function. And the chain rule says, take the derivative of the outside function, stick the inside function inside of it, and then multiply by the derivative of the inside function. And the chain rule is very important. Like, you use it, well, I don't know if I need to compare these things, but you use it far more often than you use the quotient rule, for example, at least in my personal experience. So let's see if we can work through an example. And we're kind of limited in the examples we can do because we're pretty limited in the derivatives we know how to take. We know how to take the derivatives of power functions, and we know how to take the derivatives of things built up from power functions like polynomials. Let's look at the derivative of 1 plus x squared raised to the fifth. And we're going to take derivatives that look like this so often that ultimately we'll just memorize a rule that we call the generalized power rule for dealing with it. But let's try to take care of it using the chain rule. So what you have here is composition. You've got something raised to the fifth. So that's a power function. But it's not just x raised to the fifth. It's a polynomial raised to the fifth. And in terms of composition, what's happening here is that f of x equals x to the fifth, and g of x is 1 plus x squared, and we've got f of g of x. And about 9/10 of using the chain rule is learning to look at something like this, a polynomial raised to the fifth power, and quickly realize that this is a composition and that this is the outside function and that this is the inside function. X to the fifth is the outside. The polynomial is the inside. So what's the chain rule say to do? It says to take the derivative of the outside function. Well, the outside function is the fifth power. To take its derivative, the 5 comes down and it gets reduced by 1. And you'll notice that I didn't write the derivative of f of x. I didn't write 5x to the fourth. I wrote the 5 and I wrote the 4, and then I left myself some room. Because according to the chain rule, after we've taken this derivative, we should stick in the inside function. The inside function is the quadratic, 1 plus x squared. So we've got 5 times 1 plus x squared raised to the fourth. But we're not done, because according to the chain rule, we should multiply by the derivative of the inside function. This inside function is the quadratic, 1 plus x squared. Its derivative is 1 plus 2x. And there is the derivative of the function. The derivative of 1 plus x squared to the fifth is 5 times 1 plus x squared to the fourth, all multiplied by 1 plus 2x. And as I say, I mean, if you're not really feeling this, if you're not really feeling this decomposition, we are just going to memorize a rule shortly that we'll call the generalized power rule, so that you can just take the derivative of something like this very mechanically. Having said that, we will come back to the chain rule when we are looking at implicit differentiation and related rates. So learning the generalized power rule doesn't mean you can ignore the chain rule. Even though this is an applied calculus course and power functions, at least so far, are the only functions we have, you do need to memorize the chain rule as well as the generalized power rule. And the generalized power rule we'll leave as its own video. Well, and this video here.